Hello, hello, how are you? I'm explaining today the topic of chemical equilibrium, which is a very noisy topic for most of the people. For me, it is my favorite topic. If you stayed with us, it's going to be 1 or 2 hours, but it's going to be fantastic. And I promise you, it will be the best topic that you will ever have. We have two types of chemical reactions. We have the irreversible chemical reactions and the reversible ones. What are the irreversible chemical reactions? If you bring a paper and burn this paper, you will get ashes and vapor. And let me ask you a question. Can you bring the ashes back into paper? No. Why is that? This is a one direction reaction. It never come back unless something is invented in the future. I don't know. If you are watching this video after 500 years or 100 years, don't mock me. At our time, you cannot put the ashes back into the paper by any way. So if the reactants change it into products and stop, the reactants are consumed. If you have a reaction in which H reacts with Cl and forms HCl and you cannot put it back again, then this is called irreversible. Irreversible means it's one direction. It cannot come back to the reactant's way. There is actually a strange type of chemical reactions which is a little bit crazy. When you bring calcium carbonate, what is that? This is marble. Do you know marble? If I get marble and break it down into powder or small pieces and I give it some heat, it's gonna break down. Yeah, with some heat, it's gonna make something called calcium oxide and carbon dioxide gas will be released. If I am able to contain this all inside one container so that the carbon dioxide doesn't run out, then something very strange is going to happen. What is going to happen strange? The carbon dioxide is going to miraculously react with the calcium oxide and make the calcium carbonate again. Are you kidding me, Mr.? Yes, it's going to happen. Why? Because this is called an equilibrium. No, it's called a reversible reaction. Then there are two arrows. First time for me to see this. No, for you, I'm saying you. For me, I've seen it a lot. The chemical reaction in equilibrium has two directions. It's an irreversible reaction with a small condition that I will tell you about. It's a list of conditions actually I'm applying. So the calcium carbonates forms calcium oxide and carbon dioxide, and the calcium oxide forms carbon dioxide, reacts together to form the calcium carbonate again. So there are two ways. There is a forward direction and there is a backward direction. A forward direction goes from the reactants in the product, and the backward direction, the products are making the reactants back again. Is this crazy? No, it's not crazy. This is what's gonna happen. So let's see how this is happening and why this is called an equilibrium. Okay, so this is not equilibrium yet. Equilibrium, there are three cases. The first case is a crazy case. The way or the speed, you have taken the chemical reaction rate, right? How fast the reaction is happening. If the calcium carbonate is forming calcium oxide and carbon dioxide in a very fast rate, let's say one decimeter cube of carbon dioxide is formed per second, while going back from carbon dioxide and calcium carbonate takes 10 seconds, then this is a reaction which is not called equilibrium. This is case number one. Case number one, the rate of the chemical reaction, specifically the forward reaction, is much faster than the rate of the backward reaction. Is this equilibrium? No. If I have a buzzer, I will press the buzzer now. I don't have a buzzer. Case number two, the backward direction is much faster. The rate by which, why is that? I don't know, but I'm just giving you an example. The calcium oxide plus carbon dioxide rate going to calcium carbonate back is in 2 seconds, while going from here to here is in 10 seconds. So is this equilibrium? No. In this case, the fast reaction is the backward one. The rate of the forward reaction is lower than the rate of the backward reaction. The rate at which calcium carbonate forms calcium oxide and carbon dioxide is lower. Then is this equilibrium? No. Where is our equilibrium? This is our equilibrium, Mr. Equilibrium means I have a chemical reaction which is reversible, and this chemical reaction, the rate of the forward is equal to the rate of the backward. This is the chemical reaction which is equilibrium. Let's imagine that I have a line in which there are a couple of cars going from the left to the right and right to the left. So let's imagine one small car. I'm not drawing it very well. And another car. And let's copy it. So there is 4 here and 6 here. And I have two more cars, but here. Two more cars, but here. Let me imagine that the rate of the reaction, which is two cars are going here at the same speed as two cars going here. Let me remind you if you forgot the numbers. So I'm going to say that I'm going to start with 6 here and 3. Let me change the numbers to be equal to something else. So I'm going to start with 5 here and 3 here. Why? It's like that. I've just chosen this number. If the rate at which the car is going from here to here, let's say 1 from here to 1 from here, and then 1 from here going, and then 1 from here going to here, and then 1 from here going to here, and then 1. So the rate at which the forward reaction going from the left to the right, reactants to product, is the same at which I can choose another car going from here to here. There's another car chosen, but it's still the same rate. 1 here and 1 here. So the rate of the forward reaction is equal to the rate of backward reaction. What is the concentration? The concentration here is 5 and here 3. It's fixed. The concentration is constant concentration. It never changes. So whatever you do, if you take 2 every time, if you take 2 every time and remove 2 every time, still 5 and 3. Then you take 2 every time. The rate is 2 now, not 1, right? The last time the rate was 2. The rate is 2 this time. If you take 2 and then you put 2, I forgot the wheel somewhere. The wheels. If you get 2 and take 2, if you get 2 and take 2, if you get 2 and take 2, what is the concentration? The concentration is, I will take 2 again. Still, I'll take 2. So 5 and 3. Did you watch me? I'm not doing any tricks. It's 2 going and 2. So the rate is still 2 and 2. If you make 3 and 3, it is still the same. So if you make 3 go here and 3 go here, it will be the same. It will stay 5 and 3. When you have the rate of the forward is equal to the rate of the backward all the time, the rate of the reaction is constant. If you have a restaurant and inside your restaurant you have 5 people eating inside and 3 people are waiting and they are very hungry to go inside my 5-star restaurant, and you are closing. Take care. In order the reaction to happen all the time, the system has to be closed. Do you remember what did we say here? Here it has to be closed so the carbon dioxide does not go out. Here has to be closed. If you did not close this system, no matter can go. It's closed system. There will be no equilibrium. Closed system. There will be no equilibrium. If you did not close this system, the system is not going to be in equilibrium. Some cars are going to go out. So condition number 1, the rate of the forward reaction must be equal to the rate of the backward reaction. So one person going from the door here and one person going inside. I choose the same number. That's why I changed the numbers last time. 5 and 3. One person going inside. You can change the rate. You can change the rate. You can make it 2 and 2. You can make it 3 and 3. But remember, it has to be the same rate. So you took out 2. It has to be equal rate. You bring inside 2. If you take out 3, you have to bring 3. If you take out 4, you have to bring so on. So the rate has to be equal. Here I make whatever rate. So forward is 1, backward is 1. Forward is 2, backward is 2. Forward is 3, backward is 3. If you kept the same rate, the concentration is going to be fixed. The concentration is going to be 5 and 3 forever, forever. We call this the chemical equilibrium. Forward rate is equal to backward rate. Concentration is not equal. Take care. This is mistake number 1 students make. Is 5 equal to 3? No. Is 5 equal to 3? I can change numbers. I can make 10 and 2. I can make whatever numbers I can make. I want. I can make 10 and 2. 1 and 1, 2 and 2. So the concentration can be different, but the rate is the same. The concentration will be, don't ever say equal. This is mistake number 1. Constant concentration. The concentration is constant, not the concentration is equal. If you set the concentration equal, then you mean that this number should be equal, which is not necessary. The concentration might be equal by chance. It can be 5 and 5. So I can have 5 cars. I can have, or 5 people. So I can have 5 people here and 5 people here, and the rate is equal. Yeah, it can happen, but it's not necessary. The constant, 5 and 5. So I'm taking 2 and I'm putting 2. So it stays 5 and 5. The concentration here is equal, yes, and constant. So it's not important to be equal. It has to be constant concentration. Don't say equal, say always constant concentration. This is what is necessary. Okay, Mr. If you make the reaction and it is like that, so actually you don't see the reactions happening. In the chemical reactions, I have two things happening. I have the molecules showing each other. So H2 reacts with O2 to form 2H2O. 2 to form 2 of the H2O. I have 2H2, so I have 2 from this. So I have 2 from this reacting with one of these to form what? To form two water molecules. I have four black, four blue, and two red. So what is the reaction? You have H2, 2H2 reacted with O2 to form what? To form 2 from the H2O, right? I don't see the small things. I don't see what's happening. So microscopically, what is microscopically? The number of atoms, the number of molecules, the breaking of the bonds, the making of the bonds, I don't see it. It's very tiny. I call it microscopically not because I see it microscopically, because I cannot see it, because I cannot see it. So microscopically, I cannot see it. Microscopically, I cannot see it. So what is microscopically? Anything that I cannot see is called microscopically. Macroscopically, the reaction is what is constant. So in front of my eyes, the amount of H2 and O2 and H2 is O is the same every time. So the amount is the same every time. What is the meaning of the amount is the same every time? The amount is the same every time means that the concentration is constant. Number of cars, number of people in the restaurant, it's fixed, 5 and 3. 5 and 3. You come after 1 year, 5 and 3. You come after 10 years, 5 and 3, as long as the rate is equal. So the number of people inside the restaurant and number of people outside will be the same. The chemical reaction, the concentration of the reactants and products will be the same. Macroscopically, there is no change. What is the meaning of macroscopically? In front of my eyes. So the pressure that macroscopically means I can see, I can measure. So anything macroscopically means I can see and I measure the pressure, the volume, the color, no change. Why? Because I don't see any change. If I have one person making a hole, so this guy making a hole, he's digging the hole, taking the dust out. And at the same rate, this guy is closing the hole. He's putting the dirt back in. So every one of them has his own shovel. And the reaction, actually, there is change, but I don't see it. Why? In my imaginary example, I don't see because microscopically, I can't see the molecules reacting. I can't see this breaking, and I cannot see this making. So that's why it's microscopically. There is changes. There is changes, but I cannot see it. I cannot, I cannot see it. Macroscopically, there is no changes. In front of me, the number of cars is fixed. The number of people inside the restaurant and outside is fixed. The, the whole is the same. If you come after 1 year, these people, are you working? No, I swear I was working. So what happens? There is no change in the whole. Why there is no change? Because the rate of this guy, which we'll call the forward traction, is equal to the rate of backward. So what is equilibrium? Equilibrium is a reaction in which the rate of the forward reaction is equal to the rate of the backward reaction. The concentration is constant. Never say equal. The concentration is constant. The pressure is constant. The volume is constant. Anything that I can see or measure, any macroscopical process, any macroscopical process that I can see or measure will stay fixed. Why does it mean say? Oh, because here you don't see any changes happening. You don't see any changes happen. While in fact, microscopically, so there is no changes here. While in fact, microscopically, you can see no nothing. You cannot see it. So I cannot see it, but there is change. So there is change even if you cannot see it. So let's start to see some of the questions together and see if we can answer them. A system containing a constant amount of matter. This is the system that we said we cannot do anything come inside or outside. So the system that contains a constant amount of matter with all this matter at the same pressure is called a closed system. There are three types of systems. The system that does not allow anything to go inside or outside, either heat or matter. And there is system which can allow heat to go inside or outside and matter not. So the heat can be, this is completely sealed. This is completely sealed system. If it is closed only, no matter can go outside or outside. And there is open system. This can allow matter to go inside or outside. This is an open system. So matter and heat can go inside and outside. Our system is a closed system. Why you are explaining this? Because this is an important condition, because this is an important condition for the, huh? Yeah, you can say it. This is an important condition for the equilibrium. You have to have the system closed. Now, which of the following are considered as macroscopic? Macroscopic, I cannot see. I see. I can measure the concentration. I can measure the pressure. I can measure the color. So anything that you can see, that you can measure, that you can feel, that can hit you in your face is a macroscopic. Microscopic does not mean that it is seen with a microscope. Microscopic property means that it is microscopic property means it's very tiny. The mass number, the atomic number, the reaction, the bonds making, the bonds breaking. Okay. Next question. I have a reaction here. This is equilibrium. Carbon monoxide reacts with nitrogen dioxide to form carbon dioxide and NO. When it reaches equilibrium, when all NO2 would have changed to NO, no, you did not attend the lesson. At the beginning, we said if you are having a reaction going in one direction, it's called irreversible. This is not our topic. The first condition, there should be two ways. How come you are going to say that this is dynamic equilibrium? The forward is going the same speed as the backward if there is one direction. So if you said that there is one direction, it's not going back, so all have changed to this one and it's not going back again, so this means that it's not equilibrium. When the forward, so this is of course 100% wrong. When the forward direction is equal to the reverse, yes, this is the definition. Forward is faster. No, we said nothing is faster. We said case 3 where they are both equal. So not this one, not this one. When changes can no longer be observed, yes. When you cannot see, when the constant number of people in the restaurant, when the constant number of cars here and here, this is equilibrium. Consider the following reaction. Again, do you remember we talked about this one? When the equilibrium is reached, when the pressure of the chemical system rises, no, if you said that, you did not attend. Rises, no, not rises. The system, all macroscopic are constant. The pressure is constant, the concentration, the color, everything is constant. This is a system at equilibrium. When the pressure measures remain constant, yes, we will do this in green. It is very good, it's correct. When we can detect an evidence of change, we said equilibrium means macroscopically in front of my eyes, I don't see anything. So I cannot detect. If I can detect, it's not equilibrium. There is no changes. We can detect no more evidence. Very good. This is equilibrium. When macroscopic properties become constant. Yes, this is the meaning of this one. Have a look at it again. Did you get it? Go back. Understand. Okay, this also can happen in physical changes, not only in the chemical changes. So I have one container, I have closed it, so it will be closed system. Give me a better lid. I cannot make a good lid. And then this is water molecules. The water molecules are heating up, and let's say this is water, should be colorless. And then some of the particles are going up. When the water goes up, there is H2O. And originally there was some oxygen and CO2. Why is that? Because this is air. So there was molecules of air and molecules of water here. So this is gas now, and this is gas. After a while, the gas becomes saturated. Some particles come here. It cannot take any more gases, so it stops taking. Let's say it took 5 particles of water. Then after that, any extra particles of water going up is going to go down, and then it will make condensation. So I have two processes here, physical process this time. The evaporation and the condensation, they are going in opposite directions. If the gas above the liquid is saturated, this means that the rate of evaporation becomes equal to the condensation. Whenever one particle tries to go to the restaurant, another particle goes down. So this is equilibrium now. So this is equilibrium. This is physical changes equilibrium. So again, the risk saturated. You cannot take any more. You remember when we are in humid temperature, why there is humidity? The water inside the air is too much. So on your skin, you have some sweat and you are trying to get rid of this sweat. Why you are trying to get of this sweat? When you are sweating and this is evaporated, you feel cool. You feel cool. But if you are not able to sweat, you will not feel cool. Why you are not able to sweat? Because the water tries to go up and then, sorry, it's all blocked. We have enough water to fill. We have too much water. The weather is humid. The humidity is very high, means the water inside the air is too much. It cannot take extra 2 drops from your skin. Not even 2 drops. Please let it sweat. No, it's very humid today. That's why you feel sticky like that. So fill in the blanks again. I'm not gonna draw this again because actually I need it. So now let me just take the picture from here, steal it, and we are still here. But then we said that there is water vapor and there is air. So both of them are gases. So this is gas one, this water vapor, for example, and then there is air, let's say this gas 2. Every one of them has a pressure. So this is the total pressure of them. This is the pressure of water and this is pressure of air. So what do we call this pressure? We call it partial pressure. So the pressure of this vapor is actually a partial pressure, right? Not the total pressure. It's a partial pressure of the liquid in the gaseous phase. What does it want to say? Is equal to or less than the of I'm not able to find the answer. Let's continue reading. Above the liquid, when the rate of evaporation is equal to a rate of condensation. We said that the rate of evaporation is equal to the rate of the condensation. Is equal to, so I will pick equal to, or the same as, so I'll pick the same as. When the rate of the evaporation, we said it's blocked, we said that there is no more water coming up. So the rate of going up is equal to the same as the rate of going down. But what is the answer of this one? The vapor pressure up here of the liquid is what? Is partial pressure of the liquid in the gaseous phase, right? Because I said here there is up two gases. Partial pressure of it is from water and partial pressure from it is air. Which of the following indicates that the system is sealed container? Sealed container or condensation occurs at the same rate, right? Condensation and evaporation occurs at the same rate. And the partial pressure is equal to the vapor pressure as equilibrium. What is the partial pressure means? The pressure of the water vapor. Which water vapor? The water that's evaporated from here, change it into vapor up here. What is the partial pressure of this water? Equal to the vapor pressure at equilibrium. If you don't understand it, let me explain it to you in another way. If you don't understand it, I'll explain it to you in another way. You are saying that the pressure exerted by the vapor molecules is called the equilibrium vapor pressure. And the partial pressure of water is equal to the vapor pressure of the liquid at this temperature. So in summary, in short, at equilibrium, the pressure of the water vapor is equal to the vapor pressure. It only depends on the temperature, and we'll explain this later if you wish in the comments. Okay, let's continue with that question. So we said that the next question is the partial pressure of a liquid is equal to what of the liquid? The partial pressure of the liquid is equal to the the vapor pressure is the partial pressure of the liquid in the gaseous phase. Why it's called partial pressure? Because I have a mixture of gases here. This is water. This is water. When the water comes up, it becomes water vapor. And what is inside also? The air. So there is mixture of gases. We know that the mixture of gases, pressure of the air plus pressure of water vapor gives me the total pressure. Sorry.
فيسمونه partial pressure.
Yes, احنا كنا واخدين قبل كده البارشال بريشر هو البريشر اوف جاز 1 and gas 2 صح؟ What is the first gas? It's water vapor. What is the second gas? It is air. It is air. So there are two gases here inside. The vapor pressure of the liquid, the vapor pressure is actually a partial pressure because it's not the total thing. In the gaseous phase above the liquid, When the rate of what is equal to the rate of what? When the rate of the evaporation is equal to the rate of the condensation. Okay, so let's continue with the recording. What is the next question? The next question is telling me, Mr. I have the equilibrium, everything is okay, the forward is equal to the backward. Now, which of the following indicates the system is a sealed container has reached equilibrium? We said it has reached equilibrium when condensation occurs before evaporation? No. Evaporation occurs before condensation? No. The partial pressure of the water equals the vapor pressure at equilibrium? Yes. This is correct one. When the partial pressure of the water here is equal to the vapor pressure, then this is equilibrium. Also when the rate of the condensation and the evaporation is equal. We said equilibrium is two reactions happening in opposite direction at the same rate. Very good. Okay, the next question is telling us this is a chemical equilibrium, Mr. This is a chemical equilibrium. And if you don't remember what is chemical equilibrium, I will remind you, Mr. A chemical equilibrium in any reaction, let's imagine that I have H2 reacts with oxygen to form water. So I have two reactions. One of them is called the forward. The forward is always the reactants that going to the products. So this is called the forward. Why we call this the forward? Because this is chemistry. Chemistry is like English, right? I'm writing from left to right. So this is forward. What is the backward? From the right to left. If the water is broken down into H2 and O2 one more time, I will call this what? Backward reaction. So H2 and O2 to H2O, this is forward. H2O into H2 and O2, this is backward direction. Why it's called backward? Because I don't write English from left to right. I write it from right to left. And chemistry is right like English. It's from left to right. Okay. Something very important here to understand, because students always mess up. What is the forward reaction? When I say the reaction is, when always I say the reaction is, what do I mean? Forward or backward? I mean forward. What is the meaning of this, mister? When he is talking about chemistry and equilibrium, I usually see the book talking about three things. He will say the forward reaction. So I understand he's talking from left to right. Or he says the backward reaction. So I understand he is talking about from right to left. Sometimes the book is a little bit vague or mysterious. He says the reaction. When he says the reaction, he is talking about what? Forward. Take care. When he's saying reaction, without saying forward or backward, what he is talking about? He's talking about the forward. How did you know? Imagine you are learning to drive a car, and I'm teaching you. Then I'm telling you, drive the car. How will you go? Forward or backward? You will go forward. Oh, I didn't tell you anything. I told you just drive. How did you connect drive to forward? Because this is what? This is the default, mister. This is the default. You will never go backward unless I tell you. إلا إذا كنت أنت حزلقوم. If you are حزلقوم, you will go backward. But whenever you are talking about driving, you will go forward. The chemical reaction is the same. If I told you the reaction, you will assume that I am talking about what? The forward. You will assume, because this is what? This is the default. Please save this in your mind. We are going to need it now. So in the chemistry exam, he will say the forward. So he means the forward. Or he says the backward. He means the backward. Or he doesn't say anything. If he does not say anything, when he says the reaction, then he is talking about this one, because this is the default. Okay, let's see the next question, which is very important. We said that there are three cases, right? Do you remember the three cases? First case, the forward is faster than the backward. Is this equilibrium? No. Second case, the forward is slower than the backward. This is not equilibrium. Third case, the rate of the forward reaction is equal to the rate of the backward. What does this mean? The rate by which H2 and O2 forms H2O is equal to the rate by which H2O is breaking back into H2 and O2. This is what I call equilibrium. This is what I call equilibrium. When the concentration of H2 and O2 and H2 is what? Is equal? No, it's not equal when the concentration is constant. What does this mean? It means that if I come and see the reaction at any time, I will see that H2 amount did not change, and O2 amount did not change, and H2 amount does not change. Yes, it's like the cars and the people in the restaurant. 5 people inside, 3 people outside. It stays 5 inside and 3 outside all the time, as long as the rate, one is going in and one is going out. One is going in, one is going out. As long as the rate and equilibrium is there, the concentration becomes not equal, constant, because here is 5 and there is 3. Okay, let's see the first question. Before the equilibrium state of reversible is reached, you are talking about the reaction when the equilibrium is reached. But what if the equilibrium did not come yet? I just started the reaction. Is there equilibrium when you started? Of course not. Of course not, because when you started the reaction, there is only H2 and O2. How come there is backward reaction? I did not make the products yet. So if I did not make the products yet, how come there is a backward reaction? So at the beginning of the reaction, the question is telling me at the beginning of the reaction, the rate of the forward reaction increases and the rate of the backward reaction decreases. Mr. في الأول, I have H2 and I have O2 and I don't have anything here. After a while, H2O is going to form. I will have 2 molecules of H2O. So at the beginning, the rate of the reaction, when you begin at the rate of the reaction, you will see the graph like that. What is the graph? You must look at the graph. The forward reaction is high and it starts to decrease. The backward reaction is very low. Why it's low? Because at the beginning there was nothing. At the beginning, ما كانش في water. There is no water. So there is nothing to break down. There is nothing to break down. So at the beginning, the rate of the forward, which is this one, is high, and slowly, slowly, what happens to it? It decreases. Why it decreases? Because this concentration starts to decrease. So at the beginning, the rate is high, and there is zero backward. Why there is zero backward? Because nothing of the products is there yet. So there is zero backward. Then slowly, slowly, what happens to the backward? It starts to increase. Why it increases? Because there is H2O now that will start to make H2 and O2. So at the beginning, the rate of the backward is 0. Why the rate of the backward is 0? Because there was no H2O at the beginning. Then slowly, slowly, the rate of the backward starts to rise. And what happens to the rate of the forward? Slowly, slowly, it decreases. Why it decreases? Because the concentration of this one and this one starts to decrease. It's like I'm making a salad. After a while, I will slow down. Why I will slow down? Because my tomato and cucumber is finishing. So even if I'm working very fast making the salad, after a while, I will slow down. Why I will slow down? Because already I have very little from the tomato and the cucumber. It's all has changed into salad. That's why I will, even if I'm very fast, I will have to slow because this is depleted خلاص. But after a while, the salad will start magically in our chemical equilibrium to change back into cucumber and tomato again. This doesn't happen in reality, but in equilibrium it's happening. So it will go back and make this one. So that's why the rate of the forward slowly goes down and the rate of the backward slowly increases. And when you reach equilibrium, this is the equilibrium point. This is the time. Let's say this is the time at equilibrium happened. What is happening? Mister, you told me when the equilibrium happened, what is happening? The rate is what? Equal. The rate is what? Equal. So the rate of forward is equal to backward. So how do you see this in the graph? The rate is constant. The rate of both of them, this is the rate. It's equal rate. So it's equal rate, not equal concentration, equal rate. So this is the right one. Mister, why this is wrong? Because this one is telling me, that after equilibrium happened, the reaction stopped. The reaction stopped. So you are same like the guy who was talking about the 2 people who are digging the hole. Do you remember of the example of the hole? You are like the manager now. If you said that this is the correct graph, you are like the manager. Why you are like the manager? Because you are telling the reactions you are not happening. While equilibrium does not mean the reaction stopped. it means the reaction are still happening, but in both directions. Do you remember the example of the people making the hole? One of them is digging the hole, and one of them is putting the dirt back, and they are in equilibrium. What is the meaning of equilibrium? They are both working at the same rate. The guy is making the hole at the same rate the guy is closing the hole. When I see them, Salaam alaikum, what did you do in this last week? We have been working very hard. But you are working very hard. How come I don't see any change? The whole size has not changed over a week because the work of this guy is canceled. So can you say that these people are not working? Can you say that the reaction has stopped? No, it's still going on, but what? At the equal rate. So if you said that B is correct, you will be like the manager who is saying that the reaction has stopped here. No, then you are wrong. The reaction is still happening, but what? The rate of this one is equal. That's why they are having the same line, because let's say this is the rate is 5. So the rate of this one decreased until it become 5, and the rate of this one become 5. So the rate is equal. The concentration is not equal. The concentration is constant. So this is wrong. This is right. Why this is wrong? Because if you said that this is right, then you are saying that the rate is not equal. You see, this is the rate. Let's say this is rate 5 per second, and this is 3 per second. Or this is 10 per second, and this is 5 per second. If you said that C is correct, then you are saying that the rate is not equal. While we said the rate is equal, yes, the rate by which the people going inside the restaurant is equal to the rate by which the people leaving the restaurant, right? That's why it is chemical equilibrium. That's why it's chemical equilibrium. If you said that C is correct, this means that one person is going outside and 2 persons are going outside, or 3 is going outside and 5 is going outside. If the rate is like that, is this equilibrium? No, because if 3 people are going outside and 2 going inside, what will happen inside the restaurant? What's going to happen? People are going to pile up inside. The people will increase too much, and here there will be nobody, right? Because the rate of the inside is much faster. So you cannot say C. If you said C, the rates are different. Okay, why you cannot say D? Because this is crazy. This is totally crazy. If you said that the rate of the reaction of forward after the equilibrium happens starts to increase again, and this one starts to decrease again, this is not equilibrium. Equilibrium has only one meaning. After equilibrium happens, the rate of forward is equal to the rate of backward. So let's answer the question now. What does the question is asking me? Now I can answer it from here. Remember this graph when you are answering. Why remember? I will put it here. So this is the correct one. So this is the correct one. So the first question, what does the first question? Let's answer them. They will be very easy now. One of the most difficult questions is this one, but now we understand, so we are going to solve it. Before the equilibrium happens, before you reach the equilibrium, قبل ما الناس اللي بتخش وتطلع تبقى قد بعض. What happens to the rate of the forward? It decreases. What happened to the reverse reaction? It increases. So the forward slowly decreases and the reverse increases. Okay, so, and the reverse reaction increases. When you reach at equilibrium, the rate of the forward and the backward is what? Is equal. Once you reach it here, the rate of the forward and the rate of the backward is equal. So you will choose equal here. Okay, and then the concentration are what? Let's see, will you make the mistake? The concentration is what? Constant or equal? Constant. Don't say the concentrations are equal. The concentrations are constant. If you said equal, you will be like the guy who is saying that it's a must that this number equals this number. No, it's not must. The numbers are fixed. It will be 5 and 3 here all the time, but not equal. It's not necessary that it should be 5 and 5 here. So the concentrations will be what? What will be the concentrations? Constant, yeah, mister. The concentrations will be constant. Okay. The chemical equilibrium is referred to as dynamic. Why it's called dynamic? Why do I call it dynamic? Dynamic means the people are working. Dynamic means that there is equilibrium because these two guys are working. One is digging and one is closing the hole. Are they stopping? No. If they stopped working, لو ضحكوا عليا بقى، لو قالوا لي if they laughing about me and they are tricking me and telling, oh, we are working and they are doing nothing, so I will see the same thing. I will see the same thing. There is no change in the whole. But this case, it will not be dynamic. It will be equilibrium also because there is no change, but it will be static. Static means they are not doing any work. Means static equilibrium means that there is no change macroscopically to my eye. Macroscopically, there is no change. It's constant. And dynamic also, there is no change to my eye. What is the difference? Static means microscopically also there is no change. حتى في الميكروسكوبيكally there is no reaction. But macroscopically, dynamic means microscopically there is change. This is equilibrium. This is equilibrium. There is no change in front of my eyes, but actually they are working. So chemical equilibrium is referred to as dynamic because the existence of two opposing microscopical. So microscopically, there is two opposing processes that continue to take place at what? At the same rate or different rate at the same rate with no what? With no what? With no macroscopical changes. With no macroscopical changes. Again, chemical equilibrium is to refer to dynamic due to the existence of two opposing forces, processes that continue to take place simultaneously at the same rate, with no macroscopically. In front of my eyes, I don't see anything. Macroscopically, there is no changes, but actually there is a change. So where is the graph? This is the graph. Okay. So select the picture that presents a state of equilibrium, a constant blue flame or a Bunsen burner. This is not equilibrium, mister. This is not equilibrium. Why? Because we said one of the most important conditions of equilibrium is that the place is what? It's closed. What happens if I did not make the place closed? Like some people can run out of the restaurant. Then it will be equilibrium? No. Why? Because one person was able to run. So what happens if the door is open? Oh, I'm not controlling the equilibrium. Some people will go from here. So the rate of in and out is not controlled. So it's not equilibrium. So I have to keep my system what? Closed. Take care. One of the most important conditions of the equilibrium is your system is closed. Is your system is closed. Is the system closed? No. It's open to the air. The gas will go outside. A part of the river in which the flow of the water is constant? No. An unopened bottle, this is equilibrium, mister. It is closed system. The system is closed. A part of the river in which the flow of the water is constant. I'm not sure about this one because water might be evaporated, but I will say that this is the right one. If the teacher considers that the water can be evaporated, then it is not equilibrium. If the teacher considers that the amount of water is fixed, which I don't think so, then it's not equilibrium. Equilibrium, you have to have your system what? Closed system. It has to be what? A closed system. If the system is not closed, it's not equilibrium. Some people will run. Some people will run out. Okay. Okay. The next part in equilibrium here, there is a physical equilibrium also. There is two processes happening. One process is iodine is dissolving. One process it's precipitation. So two processes happening. Iodine dissolves and then precipitates. Iodine dissolves and then precipitates. When there is equilibrium, when the rate of precipitation is equal to the rate of precipitation equal to the rate of dissolution. So there is no more iodine is dissolving. This is equilibrium. If you said this is equilibrium, this is wrong because he said still dissolving. And no more iodine is dissolving. Mister, can you remind me, are the people working or no? The people are working. Are they working at the same rate? Yes. They still work? Yes. So still dissolving. This is equilibrium, mister. This is equilibrium. No more iodine is dissolving. This is not equilibrium. Again, because if you said that the people are working but not at equilibrium, will be like the manager. Don't be like the manager. If you want to be in equilibrium, don't accuse the people that they are not working. The people microscopically are working. It's still dissolving. It's your eyes that cannot see it. Macroscopically, you cannot see it. but they are actually working all the time. So what is the answer? This is equilibrium. Equilibrium means that there is work done, but you cannot see it. Okay, what is the next question? Which of the following seals flask indicate a saturated vapor equilibrium? Huh? When there is two arrows, the two arrows should be at the same rate, or the evaporation is faster. How do you know evaporation is faster? Because evaporation is bigger than condensation. How do you know that condensation is bigger than evaporation? Where is equilibrium, Mr.? Here. Equilibrium means the rate of evaporation of the gas is equal to the rate of condensation of the gas. Two processes happening at different directions, opposite directions, in the same rate. If the rate is equal, it is equilibrium. Mixture of N2O2 and N2O4 gases is sealed within a tube at constant temperature. Which of the following would you expect to happen? NO2 turns to N2O4, but N2O4 does not return. Mister, if you said like that, then this is one-way direction. And we said there is no relationship between equilibrium and one-way. The rate of N2O4 turning to N2O2 is the same. Yes, yes, this is equilibrium. The rate of this one is lower. No. N2O4 turns into NO2, but this does not turn. لا. NO2 turns to N2O4 at the same time. Yes, but it's not necessarily correct. It should not be only at the same time. It should be at the same rate. If the two processes are happening at the same time, but at different rate, then this is not equilibrium. Then this is not equilibrium. That's why we said the equilibrium is this one. Because these two are also happening at the same time, but at different rates, so it's not equilibrium. This one is also happening at the same time, but at different rate, so it's not equilibrium. This is only equilibrium. Why? Because not only they are happening at the same time, but at the same rate. So what is equilibrium? Two reactions happening at opposite direction, happening at same time, happening at equal rate, happening in closed system. Concentration is constant. Concentration constant. So the amount of gas will be equal to the amount of liquid evaporating all the time. I think this is the same question. So NO2 has going on, not the same time, but at the same rate. So what can be concluded from this equation? Do you see the equilibrium sign? Yes, I see it. If you see it, this means the forward and reverse action may take place spontaneously. No, not may. It's necessary. It's happening at the same time. No, they are happening at the same time. This one and this one always present in the reaction mixture. Yes, yes. Yes, both of them are available at the same time. Do you remember when we said at the beginning the difference between reversible and irreversible? Are the reactants and products available at the same time? No. Why? Because I will see the products, but where is the reactants? Nothing. It's gone. It's finished. It's depleted. It's consumed. Only in the equilibrium, in the reversible, you will see the reactants and products all the time. You will see reactants and products all the time. So if you open the container, let's look at this reaction. The reaction is happening inside the container. If you open the container after 1 hour, what do you see? H2 and O2 and H2O. After 1 more hour, H2 and O2 and H2O. After 1 year, H2 and O2 and H2O. It's the same. What happened if you open the container of the restaurant? 5 people and 3 people. After 1 year, 5 people and 3 people. After 10 years, 5 people and 3 people. As long as the rate is what? Constant. So you will see what? As long as the rate constant, you will see the reactants and products all the time. 2 molecules of NO2 are consumed. Every 1 molecule of N2O4 is formed. Yes. No, mister. The 2 molecules of NO2 is not consumed, are produced. How did you know? 2 molecules produced, not consumed. 1 molecule of N2O4 formed. No. 1,2O4 is 1 molecule is what is consumed. So every time 1 molecule of N2O4 is consumed, 2 molecules of NO2 are formed. The reaction is fast? No. There will be twice as much? No. يبقى أنا إيه اللي عرفته? He is telling me, what did you know from this reaction? Mister, from this reaction, I can see this sign. When I saw this sign, I say these reactions are happening in the same rate, at the same container, closed container, constant concentration. You will always see this and always see this. What is the meaning always see? Means that it's not one direction. If it was one direction, after a while, this one will be finished and this is only available. But it's not one direction, it's two directions. Okay, let's see the next question. Iodine crystals are in equilibrium with iodine dissolved. We said two processes happening, iodine dissolving and iodine precipitating. Okay, what is the meaning of equilibrium, mister? It means the solution is becoming saturated. The color will be, what will be the color after a while? The color will be, stays the same. The iodine dissolved in water at equilibrium, the color will what? Stays the same. Why the color stays the same? Because it's equilibrium. We said macroscopic. Anything that I will look at, it's the same. You are not working. The numbers is fixed. Equilibrium means constant. Okay, the dissolution. What is the dissolution? The dissolution rate is equal to the rate of the iodine precipitation. So I will say the first question